clustering is also an age-old problem that has both clustering and classification have been studied quite a lot in machine learning since 1960s and so on. So clustering is an age-old problem that has been studied quite a lot in AI, machine learning, and other subjects since around 1960s. The major task of clustering is, given a lot of data points, let's say suppose you have two axes, x and y, two attributes, and you have a lot of data points. Now, can you group these data points into, let's say, different clusters? Okay, so this is different from classification. In classification, you already had labeled groups. Okay, so the groups which were labeled, and your task is, given a point, you want to decide which group it belongs to. In clustering, you're actually defining the groups themselves. Okay, you don't have the groups predefined. You're defining the groups, and probably you don't know what the labels to these groups are, because the groups are being defined by the algorithm itself. Okay, so now how do you decide which points to group as part of one cluster? Now obviously when you see visually as a human being, it is quite easy. Whatever are the nearby points, you group them as part of one cluster. Now, so in the literature, people have come up with different, what is called as distance functions. Which tell, given 2 points x and y, what is the distance between x and y? So you have probably a function dist, and which takes 2 arguments x and y, and it returns what is the distance between x and y. And normally this function, for example, if you just have a Euclidean space like this could be defined in terms of Euclidean distance, which would generally be, you know, suppose x is actually x1, y1, and y is actually x2, y2. Then the distance would be x2 minus x1 plus y2 minus y1 squared, square root of that. So this is the Euclidean distance which is quite popular, and this is an example of a distance function. There are many other different examples of distance functions which have been discovered. Now given a distance function like this, and given a lot of data points, you need to come up with algorithms which will actually group nearby points into clusters. And there are lots of different kinds of algorithms again. So you have what is called as a partitioning algorithms, and you have the hierarchical algorithms, and you have density based algorithms. These are the major kinds of algorithms. So partitioning will basically come up with spherical or nearly spherical shaped clusters, because they basically have the tendency that there is a centroid or a center of the cluster, and things which are nearby that centroid they group as one cluster. Okay, so they generally tend to give spherical or near spherical shaped clusters. Hierarchical clustering will actually come up with a hierarchy of clusters, not just a flat clustering, but you might find that, you know, there might be an algorithm which might treat these 2 points here as one cluster, and these 2 points as another cluster, and these 2 clusters themselves become part of a bigger cluster. Okay, and maybe these 2 clusters are quite close by, and so you decide to group these 2 clusters as part of one bigger cluster. So you have a hierarchy of clusters here. Okay, so those kinds of algorithms are called hierarchical clusters. And then you have density based clusters, clusterings, which basically look at the density of points in a region. So it will find that, okay, this is a dense region. Okay, so it will put all the points in this region as part of a cluster, and then it will grow that cluster depending on how the density of points are present. So it will grow the cluster in this fashion. Okay, so it will start with at a particular place, and as long as the density is similar, it will keep putting those points as part of the same cluster, and it will grow clusters of arbitrary shapes. Remember, the first partitioning based clusterings only got us near spherical shaped clusters, but density based clustering can get us clusters of any shape. Okay, so these are basically the major kinds of clustering algorithms which you will actually study in more detail. But what I want to cover next is what are the major applications of these various different clustering strategies. Why do you need to do clustering in the first place? Okay, so there are many applications. There are two basic kinds of applications. One is to find similar kinds of objects. Okay, so for example, suppose you want to form tutorial groups in a class. Okay, so you have different students and you want to divide these students into different tutorial groups. Okay, and you know that there are basically some weak students, some students who are very bright. Okay, so you might want to club all the students who are weak in specific subjects. Okay, and students who are bright in specific subjects. Okay, students who are weak in specific subjects, they need extra tutorials. Okay, so you put them as part of one tutorial group. Okay, and generally you might not have students who are uniformly weak in all subjects, but students who are weak in specific subjects. Okay, so there might be, let's say, student 1, he's weak, let's say, in subject 1, subject 2, and subject 3. There might be another student, student 2, and he's weak, let's say, in subject 2 and subject 3. And there might be a student, student 3, he's weak in, let's say, subject 4 and subject 5. Okay, so obviously, it's natural to put these two students as part of one cluster and keep them in one tutorial group. And students who are similar to this guy, keep them as part of another tutorial group. Okay, so this way, you'll be maximizing the efficiency of these tutorial groups. Okay, so basically what you want to find is find similar kind of people. Okay, and this kind of activity you want to do in lots of other places. So these might not be just subjects. Okay, they could be hobbies, for example. So you have different hobbies, and you want to group students or people based on their hobbies or interests. Okay, so because you want to form nice social activity groups. Okay, and there's another application of this. You want to form health support groups. Okay, so you'll find that there are people who have certain kinds of health problems, and generally many of the health problems, if you know, they are all 90% of what doctors say is that 90% of these health problems are psychological. Okay, so it makes a lot of sense that these people who have these particular kinds of health problems, they get together and they discuss these problems among themselves. That way they'll feel a lot of support. They'll feel psychologically at ease, and this goes a long way in treating their problems. Okay, and you could form customer groups for marketing. This is another strategy. Basically, people who are marketing, they want to categorize all the customers into different groups so that it's easy for them to target. Okay, so these are young customers, these are old customers. So for young customers, I need to approach them in a different way in order to sell my product. For old customers, I need to approach them in a different way in order to sell my product. So you need to categorize customers into different groups. Okay, and of course you have another application here for clustering email. Okay, so now previously in classification I told you about classifying email into, let's say, spam and not spam. But in general, you might not have well-defined categories predefined, but you might want to categorize all your emails into groups automatically so that you can actually look at a whole group of emails in one shot. Okay, so these are different applications of clustering of one kind, basically finding similar things, similar objects or similar people. The other kind is basically deciding on locations for an activity. Okay, so suppose, for example, there's a business chain, there's a supermarket chain. Okay, and the supermarket chain needs to set up a new shop somewhere. Okay, so a new supermarket it wants to set up somewhere. Okay, so now it looks at the city. Okay, so suppose this is the particular region. Okay, in a city. Okay, and it looks at what is the population density in different regions of the city. Okay, so there might be lot population clusters in the city. Okay, so obviously wherever there's a population cluster, you would want to have one supermarket in that cluster. Okay, so basically, so you need to identify clusters in order to decide where to strategically put your supermarkets or and or any other kinds of stores. Okay, or to plan a political strategy. So let's say there is a politician and he wants to decide where to conduct his meetings, where to promote his political activities. Okay, so he knows that he already has a stronghold in certain regions and he doesn't have much of a stronghold in certain other regions. Okay, and maybe the opponents have a stronghold in certain other regions. So by looking at clusters where he has a stronghold, where he doesn't have a stronghold, he can decide where to put more campaigns. So these are basically example applications where you want to find locations, okay, in a particular place. So the previous kind of examples were to find similar people. So these kinds of applications is to find locations. Okay, so these are two very broad kinds of applications that you can do in clustering. So that is all about clustering.